Welcome back to a moment of quiet curiosity. Tonight, we explore a theory that challenges everything we know about our own identity. We often call Earth our home, but what if we are actually visitors? What if the first spark of life didn't happen in our oceans, but on a cold, red planet millions of miles away? This is the theory of Panspermia, the idea that life can travel between worlds on the back of asteroids and comets. For decades, scientists have looked at Mars and wondered if it was once a twin to Earth. Today, Mars is a frozen desert, but billions of years ago, it was a world of blue skies, thick clouds, and vast, rushing rivers. In fact, many experts believe that Mars was ready for life long before Earth was. As you settle in tonight, let your mind wander to the ancient solar system, a time of chaos and collisions, where rocks were constantly being traded between planets. We are going to look at the evidence that suggests we might all be Martians, descendants of microscopic pioneers that survived a journey across the cold vacuum of space to find a new home here. Breathe deeply and let go of the day as we travel back 4 billion years to the dawn of life. The story of our origin might not be written in the soil beneath our feet, but in the red dust of a neighbor world that once thrived with water and warmth. Imagine the early solar system as a busy highway of gravity and stone, where the seeds of biology were being flung from one world to another in a desperate race for survival. This is not just a story of science. It is the story of our potential heritage as children of the stars. Let the heavy silence of the night prepare you for a journey across the millions of miles that separate our two worlds as we search for the truth of where we truly come from. To understand why life might have started on Mars, we have to look at the state of the early Earth. 4 billion years ago, Earth was a violent, waterlogged world. It was covered in global oceans, and it lacked certain minerals like boron and molybdenum, which are essential for creating the building blocks of life, like RNA. On a world completely covered in water, these minerals are hard to find in the right concentrations. Mars, however, was different. It was smaller, so it cooled down faster than Earth. While Earth was still a molten mess or a drowned world, Mars already had dry land, shallow lakes, and the perfect chemistry for life to begin. Scientists have found that the specific oxidized minerals needed to jumpstart life were likely present on Mars, but rare on early Earth. This leads to a startling possibility. The cradle of life wasn't here. It was there. Mars may have been the primary laboratory of the solar system, a place where the first molecules learned how to replicate. If life started there first, it would only be a matter of time before it found a way to travel. The solar system was a much more crowded and active place back then, with asteroids constantly slamming into the surfaces of every planet. This set the stage for the greatest hitchhike in history. Imagine Mars as a vibrant, rocky world with hot springs and mineral-rich craters, acting as the perfect incubator for the first single-celled organisms. While Earth was still struggling to form its first continents, Mars might have already been teeming with microscopic life, waiting for a cosmic accident to send it on a journey to a new home. This perspective shifts the center of our biological history from our own blue planet to the dusty red one we see in the night sky today. The idea of life traveling through space sounds like science fiction, but the physics are real. When a large asteroid hits Mars, it strikes with enough force to kick rocks clean off the planet and into orbit around the sun. We know this happens because we have found over 100 Martian meteorites right here on Earth. These are pieces of the red planet that fell to our ground after traveling for millions of years. The big question is, could a microbe survive that trip? Surprisingly, the answer is yes. Scientists have tested bacteria in extreme conditions and found that they can survive the shock of a massive impact, the freezing vacuum of space, and even the intense heat of entering Earth's atmosphere. If a microscopic organism was tucked deep inside a crack in a Martian rock, it would be shielded from the sun's radiation. It could stay in a state of suspended animation for thousands of years until that rock finally pulled into Earth's gravity and splashed into our oceans. For a tiny microbe, a Martian meteorite is like a natural spaceship. Once it landed in Earth's warm, nutrient-rich water, it could have woken up and started the process of evolution that eventually led to us. This means that the first living things on Earth might have been Martian immigrants, arriving in a world that was just beginning to become habitable. The journey across the void is a test of extreme endurance. Yet life has proven to be incredibly hardy. It can survive in the most hostile environments imaginable, clinging to existence in the dark cracks of stones. Every time a meteorite hits our planet, it carries the potential for a cosmic connection, a reminder that the borders between worlds are much thinner than we often think. In 1996, NASA scientists announced they had found something incredible inside a Martian meteorite called ALH-84001. Using high-powered microscopes, they saw tiny structures that looked exactly like fossilized bacteria. While the scientific community is still divided on whether these were actually alive or just strange mineral formations, the discovery changed everything. It proved that the building blocks and the potential for life are definitely there. Furthermore, our modern rovers like Perseverance have confirmed that the craters on Mars were once ancient lake beds filled with organic molecules. If we eventually find DNA on Mars that matches the DNA on Earth, it would be the ultimate proof. It would mean that the family tree of all life doesn't just stop at the Earth's atmosphere. Its roots go all the way to the Martian soil. This changes the way we look at ourselves. We aren't just observers of the universe. We are part of a biological flow that moves between worlds. It suggests that life is persistent, hardy, and destined to spread wherever it can find a foothold. It makes the universe feel a little less empty and a little more like a connected garden. When we look at the samples of rock and dust being collected today, we are searching for our own history. The chemicals found in the Martian soil, the carbon, the nitrogen, and the ancient traces of water, all point to a world that was once perfectly suited for life. If Mars was indeed the birthplace of our ancestors, then our exploration of the Red Planet is not just a mission of discovery, it is a mission of homecoming. We are looking for the fossils of our own earliest relatives, buried beneath the dust of a dying world. The most difficult part of the Panspermia theory to believe is the journey itself. How can anything survive the vacuum of space? The truth is that life is much tougher than we give it credit for. Scientists have conducted experiments on the International Space Station, placing bacteria on the outside of the station, exposed to the raw vacuum and intense radiation of space for years. To everyone's surprise, many of the bacteria survived. They entered a state of cryptobiosis, essentially turning themselves off and waiting for better conditions. In this state, they can survive extreme cold and the lack of water. When these bacteria were brought back inside and given nutrients, they woke up and began to multiply as if nothing had happened. Now, imagine a colony of these hardy microbes inside a Martian rock. This rock acts as a shield against the most dangerous part of space, the sun's ultraviolet radiation. Inside the stone, the temperature stays stable and the microbes are protected. This lithopanspermia, life traveling inside rocks, is scientifically plausible. Calculations show that a rock ejected from Mars could reach Earth in as little as several months, though most take millions of years. Even over millions of years, if the rock is large enough, the core stays insulated. This means that space isn't a barrier to life, it's a bridge. The void between planets is not a graveyard, but a vast transit system that has been moving material between worlds for billions of years. We are used to thinking of planets as isolated islands, but in reality, they are constantly exchanging matter and potentially the seeds of biology. For billion years ago, the inner solar system was like a shooting gallery. This period is known as the Late Heavy Bombardment. Massive asteroids were slamming into Mercury, Venus, Earth, and Mars. These impacts didn't just destroy, they moved things. Every time a large asteroid hit Mars, millions of tons of Martian soil were launched into space. Some of that soil stayed in orbit around the Sun, eventually crossing paths with Earth. It is estimated that every year, about half a ton of Martian material lands on Earth. This has been happening for the entire history of our planet. This means that if life ever existed on Mars, it has almost certainly been delivered to Earth thousands of times over. This grand exchange makes it very likely that the two planets have shared biological history. If Earth was hit by a Martian rock containing life during a time when Earth's own environment was just becoming habitable, that Martian life would have found a wide-open world with no competition. It would have spread through our oceans like wildfire, evolving and adapting to the unique conditions of our planet. This theory suggests that we shouldn't look for life on Mars as something alien, but rather as a long-lost relative. The solar system is an interconnected web where the fate of one planet is tied to the others. Our origin story may be a collaborative effort between two worlds, one that provided the spark and another that provided the long-term fuel for life to grow into the complexity we see today. As we conclude this exploration of our Martian origins, the reality is that the mystery remains open. The evidence for panspermia is growing, but we are still waiting for that one piece of undeniable proof. Science is not about having all the answers. It is about the journey of asking the right questions. Whether our ancestors were born in the red dust of Mars or the deep vents of Earth's oceans, the story of life is one of incredible resilience. We are the end result of billions of years of survival, a tiny part of a universe that is constantly trying to understand itself. If you enjoy these deep dives into the scientific truths of our cosmos, please consider subscribing to the channel. Your support allows us to continue researching these fascinating topics and bringing them to you in a way that helps you relax and reflect. By joining us, you become part of a community that values curiosity and the quiet wonder of the stars. We have many more journeys planned, from the mysteries of black holes to the future of human life beyond Earth. Thank you for spending your night with us and for letting your imagination travel to the ancient, water-filled craters of Mars. It is time to let these big ideas rest for now. The universe is a vast and complicated place, but for tonight, your world is calm and still. Focus on the quiet around you, breathe slowly, and let your mind drift into a peaceful rest. We are all made of stardust, and we are all part of the grand cosmic story. Thank you for watching, and thank you for being curious. Sleep well, and good night.